Today we are going to talk about ramps in ArchiCAD, and ramps are increasingly a big thing to add to buildings because of the accessibility that they provide. Because sometimes in our society we have people who are not enabled, who may have faced misfortunes and cannot access by stairs. And of course we have age groups that actually take advantage of ramps, such as the elderly, also the children, also the pregnant mothers. So these are important things to be talking about. And today we just want to explore how we can do it faster, because it's one thing that once I did it, I was wondering why I didn't do it before. And so we are going to go through how I actually did it. It's actually very, very simple. I don't know which one of you guys is able to, is with their computer and they can share a screen after the presentation, just so that we can be sure to know if we have understood the process, because it's going to be a very simple presentation and you can go in and try it as we watch and give you advice. Allow me to mute this call. Okay? Anyone who is interested, that in case at the end of the presentation they can share their screen. You can also type in the chat and I'll be able to note that, such that I allow you in. Okay, so we have discussed why ramps, but we need to know the regulations of ramps as well, because as architects we have guidelines to follow. And if you used any web browser and you started to look for what the regulations are, I'm going to pull up my web browser and ask a question. I think I should have, I'm going to type in the ramp slope, and we should get the standard ramp slope. So when you go to Google, you can see the things that are being recommended in here, and the standard says that you need 12 meters on the ground in order for you to climb 1 meter. So the most advised slope is 1 in 12. So for you to climb 1 meter, you need 12 meters on the ground. And that's a lot of space, by the way. It makes it a very expensive thing, because for a stair you just need like 3 meters, but now here you need over 12 meters to just have a ramp. So it makes it quite an expensive venture to actually build a ramp. So we can see, if we pick up this other example, we have this, which is 1 in 12 as well as the maximum, but there are some cases where you can actually use like 1 in 10. Yeah, because I have seen that happen. Yeah, you can look through the regulations depending on what your local government accepts. Yeah, so once you have that, now we can go ahead and to figure out how this did. So in order for us to do this, let me try to start from scratch, such that I do not lose people on here. So I'm going to begin with the simplest form of it, and then we can create the complex things later. So it is quite simple. So what we are going to do is to go under design and pick something called a mesh. And now we are going to start to draw this. And before we continue, previously, if you wanted to do a ramp, you would use an object, because we have an object in ArchiCAD that does that is called ramp actually. So once you type in ramp, you have something here that is done. You can see we have a curved ramp and a normal ramp, but the problem with this is that it's very hard to control. I have used it before, so I know the pain that you go through to use this. So that's why I want us to do it differently. So we're going to use a ramp today, to use a mesh today. We have someone coming in, so allow me go and allow them so they can join us. Welcome, Nixon. So let's proceed. So the first step that you want to do is pick a mesh. And once you pick a mesh, you can go ahead and draw the shape of it. So we have just discovered that we need 12 meters to cover, just to go up just 1 meter. Okay, I'll go ahead and allow that other person as well. Thanks, Joel, for joining us. So we need 12 meters to rise only 1 meter. So we are going to create a simple box here, which is going to allow us to do that. And my ramp is going to be 12 meters in the dimension 1. I'm going to press tab, and then I say 12 meters. That's the length. But for the width, that depends on how wide you want your ramp to be. In my case, I think I'm going to say 1.5. When you press tab, you should be able to put in those 2 dimensions. So you can use any size. 1.5 is like, you know, I'm imagining like 2 people passing each other, or if there is a wheelchair and someone is passing by. So now we have ourselves this mesh, which is 1.5 by 12 meters. Okay, so once you have this, you can see by default it is meant to do something else. A mesh is not meant for ramps. So we are going to just have to change it such that it doesn't look like this. So we're going to change this and just remove a cover fill. So once we get rid of the cover fill, it should look plain, something like this. Quite simple. And then we want to simplify it by raising one of the sides or either of the sides. Okay, so we are going to just do that. I'm going to quickly allow this person in. You're welcome, Jeff. So we have created ourselves a ramp, a simple mesh, and now this mesh, we just want to raise it. Now for those who have modeled for those who have modeled a landscape before, you'd know that actually this is the easiest way you can create a mesh, because you can raise the corners on this side and on this other side. So every node that you create on this thing can be raised. So I'm going to raise one of them. So when you click on any of the nodes, you have something here called elevate. So you can elevate that side. So once I say elevate, you can see that that's a point, and it has this option that says apply to all, but we are not going to use it because a ramp definitely doesn't have all sides the same height. So we're going to raise this by 1 meter because that's what we need to do. And once we do that, you can see we have this ridge line. What this ridge line means is that this point is at 1 meter high and the rest are still at 0. It just means that this point is higher. So we want to raise this one as well, because usually these two ends are at the same height. So we're going to click on this one, and you can see this comes up immediately because of course the elevate is the one which is selected, and we are going to put in 1 meter. Okay, so once we do that, you will see that it has disappeared, and that's because of course it's now along that line. These parts are higher than the rest. Now, in order for us to see what has just happened, it's best that we go to 3D. So I'll do that, and then we can see that this is basically what a mesh does. So a mesh is usually meant to make landscapes, and you can see it's already in green by default, and it is made of earth or soil. So because we want to make a concrete ramp, we just need to change some of this stuff to concrete. I think I can pick concrete. Okay, so once you type in concrete, if you're using the latest versions of ArchiCAD, you should be able to get the things faster. So once you click in concrete, even if we just disable everything else, it should be in concrete by default. So we have ourselves this kind of thing going on, where we have this resemblance of what a ramp should look like. But the challenge we have with this thing is that it's by default has only 3 modes. This is the first mode, which I can go to settings. I'm going to go to Control T into settings. We have this option, which is just a thin layer, which doesn't have any thickness. And once I say okay, you can see what I mean. It's just a plane in space. And of course, our ramps usually have thicknesses. So that's something that we need to solve. And then next, we have another option, which is this second option, which has edges around the ramp. So once we say okay, you can see we have created something, but it's hollow inside. So I hope you can see that it's hollow inside. And then the final option is the one which was there at first, which is the solid version. So for us to create a ramp, usually this is achievable and is good, but sometimes you just want it to follow the profile. So I found a hack of actually doing it. So what you need to do, and once you understand this, we will be done with the lesson, because that's how I actually achieved it. It's quite faster, because once you know how to use meshes, which you should be able to know by now if you're using ArchiCAD, then this is going to be quite simple. So what you need to do is just change this back to a plane. I'm using them here, the things that I found in the settings. So instead of going to the settings all the time, you can actually pick those things from this icon. So once you click here, you can say plane, you can change it to plane. And once you change it to plane, you can see that we have that. So all you have to do is to know how to use solid element operations, which we are going to look at. Don't be scared by it. So let's just do that. So what you want to do is to use this plane as a cutting plane. So I'm going to make a copy of it, of this thing. So I'm going to right click and I say move. Actually, even if we just said Control D, which is the copy thing, because I'm not seeing it in the options, maybe it is available when you're in plan. So I'm going to say Control D or Control Shift D, such that we have a plus, you know, that plus that says that you're making a copy. So then we go down, we are going to just create a copy down, which is going to be, what's the thickness of our ramp? I'm going to pick like 300, which is like 1 foot. And then there we have our 2 planes. Now they don't mean like much, but we are going to use this as the cutting plane for that thing. So all you have to do is to now take this back to the other shape and use this other second one as a solid element operations thing. Okay, it's just, that's the idea behind. So we are going to do that. For those who are not familiar with solid element operations, I'm going to go as slow as possible so you may get it, but it's quite a simple concept. So if you go design and you have something here called solid element operations, you can click it and we have this thing. So what does this thing do? It accepts some elements to be targets and others operators, such that you can intersect them in different ways. You have options here. You can subtract elements from each other. You can use upward extrusion, such that you cut something and then you remove the top part. Then you have downward extrusion, which we are interested in because we will be cutting something and removing the parts which are below. So, and then we have intersection and addition. And before we employ any of those, we just need to assign. Let's get the mesh and we will put it as a target, because that's what it is. We are targeting that mesh. We just want to remove parts of it. And then we use the plane that we created, the duplicate that we created, and we assign it as operator, because it's going to chop everything that is below it. And then we are going to change from subtraction to subtraction with downward extrusion, because what we want is we want to remove everything below our given form. Okay, so once we say that and say execute, we have ourselves this thing, which is quite simply a ramp of the simplest form of a ramp. So those were a few steps that I hope were very clear. You can talk to me. Do you think you understood us so far? Because that's the essence of the tutorial. Yep. Say
Hello,
something.
Nalan.
Yes, please.
Wow, that is amazing. That is amazing.
Okay. The
Yes,
steps were
yes,
clear.
yes, they were very clear.
Okay, so it's quite simple. It's just one mesh. You play with it. You play with it in order to actually achieve this. Because on the other hand, I was wondering why wouldn't ArchiCAD give us an option where the mesh has a thickness? But they have their own reasons. But I think this is a good workaround that you can use to actually achieve that. And this actually makes even making circular things even also easy as well. Okay, but that's going ahead of ourselves. That's one example. Let's look at a real life example, because sometimes we do not have a lot of space on site, so sometimes we just want to create a ramp that goes, lands, and then comes back. Okay, because we just want to conserve as much space as possible. Okay, Stephen, you're welcome. Now we are going to do a second version. So that was the first version. Let's do a second version because like we said, this is 12 meters and which means that if we want to go to a next floor, we will need two more of these, because this is 12, which is going to climb only 1 meter, and then we need another one for the second meter, and then we need another one for the third meter. So it's very tricky. So sometimes we just need to land and then go back, such that we conserve space. So we're going to do that. So let's pick a mesh like we did before, and we're going to go through the same processes. And if we wanted to use the same parameters that we used before, such that we don't go back through changing the thing, we just pick. You can pick up parameters. We can just pick this very mesh so we can reuse it. So we are going to just draw the one which is 12 by I'm going to use, I know we chose 1.5 for that depth, for people to cross themselves. And of course we need a ramp, we need a what do they call it, a landing. Yeah, practically you need a landing in this space. So a landing is supposed to be as wide as the leg itself. So the one leg is 1.5, so we're going to use 1.5 as the landing. And then of course, since there are two, it's going to be 3 meters, but of course we need some space between the two legs so they are not too tight. So we can say 3.2, so such that it's 1.5, which is the same width as our leg, and then 3.2, just because we are going to just have this duplicated here and still have the K200 in this space. Okay, so that's what's happening. We have now these two legs, and what this is helping us is that we are now creating something that occupies only this space, but it's going to climb for 2 meters. Okay, because remember, from here up to here, we are climbing only 1 meter. I should probably be writing some of these things, because I know it's easy to get lost, but it's quite an easy concept. Hopefully I do not lose anyone. So here we have just climbed 1 meter. So imagine here we have 1, here we are at 0.0. I'm going to, just trying to get this in here, 0. But then what that means, I think I typed O instead of 0. So I'm going to do that again. 0, great. And then what that means is that here we have 2 meters, okay? Because we are adding an extra 2 meters. And what it means is that in case you want 3 meters, which is the standard height of a building, you will have to expand this beyond 12 meters, okay? So you would have to get, you know, because traditionally I would calculate, let's do that just quite simply. You would just calculate and then have, let's allow this person at the door. Okay, ArcBoost, you missed almost half of the tutorial, but we are glad to have you here. So I was saying we have 15 meters, we have 12 meters for 1. So you just multiply it by 3. So you actually need 36 meters to be able to land on top of your floor. So you just divide this by 2 because we are creating 2 legs, okay? So you need 18 meters, yeah? So you need only 18. Okay, this knocking at the door is not easy, but yep, we will continue. So we are saying here we have just climbed 1 meter, and here we have climbed 2 meters. So in case you wanted 3 meters, which is going to be the case for most of the buildings, you would have to make this 18 like we saw. Hopefully I remember very well, I closed it already. So we have like 18 plus 18 to make it 36, okay? I hope that's clear. But for purposes of demonstration, we're just going to keep it simple. We have 0 to 1, we have 12 meters, and then 1 to 2, we have another 12 meters. So we need to work around this. And instead of raising things from here, I think I'm going to do them in 3D because it will be easier for you guys to appreciate, to see what's actually going on. So I'm going to go to 3D and try to do the same thing again. And to differentiate between the two, perhaps we can change the material of this slab. If we go to the settings, you can always change material of whatever you're using. So currently it's here, but it's okay. Let's just make this concrete. I'm not sure why I can't see concrete, because I think I'm in a different folder, but let's just enable everything, and then I say, come on, I think I will need to choose the highest hierarchy. Yeah. So now I just need to differentiate between the two. So let's choose O2 in this case, because I believe the other one was O3, the other one was O4. Yeah, just to differentiate between the two. Now currently we have ourselves something here which is doing the things that we have done. Let's allow these people in. Okay, so let's start. We have ourselves these 12 meters that we want to raise by 1 meter. And like I said, if you used a mesh, it will definitely help you. And let's do that. Let's just say this point is supposed to be raised by 1 meter. So we will click it, and then we say elevate. So once we click elevate, we are going to raise that by 1 meter. Okay, which is good. So you can see what's happening in real time. That point has been elevated by 1 meter. Okay, if I go around, you can see the difference between this and the rest. The rest are stuck on the ground, that is on high. But of course it doesn't make sense yet. No one will use this ramp, so we will have to raise this at the second point. And since we already did the operation before, it still remembers the operation we were still using. So we are going to elevate this. You don't have to click to hold anything, you just align it with this one, so you can see it's going to be elevated by 1 meter. So we have ourselves that leg. And that same thing is supposed to happen for these other things. Now, before we continue, I think it would be good practice for us to make it into one shape such that we do not do multiple operations and creating multiple objects. So I think before we continue, let's just group the whole thing into one thing. So we're going to say, you know what, let's add this shape. You can see what I'm doing. I'm adding to polygon this shape, and I just click on any of the edges and add this shape. Okay, so you can see I have a uniform thing, and definitely I would have to remove the parts that are still in here. When I delete those, I now have one homogeneous thing. So it's easy for us to work with just that one. Okay, so we said once you click here, you have to elevate that point. So I'm going to make sure that it is the one selected, and we raise it by 1 meter, which is good. And then we raise its neighbor as well to 1 meter, which is good. It starts to create some funky things, but in your mind, hopefully you can see what's trying to happen. And we raise that. Everything here now is going to be at 1 meter height. So just go on and raise everything. One more point left at the ground here, and make sure that it is on the 1 meter. Okay, so now you can see what has happened. It has created those two legs, but definitely we don't want to go back to the same place we started, so we want to raise this by 2 meters. So I'm just going to quickly do that. Just make sure that it is elevation that is being selected. Of course, here it's going to be 2 meters, and its neighbor as well, which is on this other side, needs to be 2 meters. So hopefully you can see what is happening. You can see that we have gone 12 meters to climb 1 meter, and then 12 meters again to climb just 1 meter. So that's 2 meters. Okay, so easy, much easier. It's a much more intuitive way to work as opposed to using an object. That's why I insist on using something like this. Okay, so like we said before, all we need to do is to first change this to a flat plane. So I'm going to just change it to a flat plane, and you can see that that's what we have. And now we create a copy that we will use to do our operation. Okay, so I'm going to select this and then create a copy of it. So Ctrl+Shift+D is the shortcut for creating a copy. So I move it, of course, holding down Shift such that it's in the vertical plane. So below, I'm going to move it by 300, which is 1 foot, just to make sure that I just have those two, copies. Yeah. So right now I'm defining these two planes. So what I need to do is to give this one some muscle, the one which is above, and then cut it. It's simple logic. So I'm going to just create this as a solid and make sure that it's the target, and select it as a target. For those who don't know where this is coming from, remember it's coming from design. I'm going to deselect such that I'm able to select some, say design solid element operations. Yeah, so once you have this dialog box, what you have here selected as the mass should be put into target, and then what you have here as the plane should be the operator that is helping us to chop everything downward. So within the drop down, make sure that you have subtraction with downward extrusion selected, because this enables you to cut any solids that are below the selected target. Okay, so once we say execute, now we have ourselves something magical going on here. So hopefully you can see the ease of use of something like this. You can talk to me now. Let me enable this other person. Franklin, you have missed a lot, but we are glad to have you here. Okay, any questions so far? Because I think the essence of the tutorial is done within less in half an hour. So this is the time where I receive questions before we receive one last example. And in case anyone is interested in trying it out such that we know that we have understood the concept, we will let them in at the end. Okay, you can unmute and say something in case you. Let me see if anyone is raising a hand. Yes, Nixon, please go ahead.
Yes, thank you, Alan. Personally, I'm just I'm glad that you're sharing some of these hacks, and I remember, I think I've been using that hack for some good time because I'm really an Archicad user.
Very good.
Yes, so it really simplifies even roofing. When we want to design roofs and what, sometimes it is really it comes in handy. So I'm just glad that it's a tool that actually we are getting to learn more and see how to use it a little bit better.
That's very, very good, actually.
Mm.
So those who haven't yet used it, please go on board, because it allows you to actually create these things much faster. And in case, of course, you're creating like a round one. Actually, I think we have two more to do, because we have a round one and the box shape one, because it's also interesting to find out how you can do it. Let me see if there is any other hand. If there is no hand, we go to the next one. Yes, Ignatius.
Yeah, greetings, my fellow architects. Actually, I would want to say thank you so much, Aknalan, for being there for us. But actually, this is a tool I've also been using for quite some good time. And I would also advocate for it that it is a tool that can really help us to design easily, especially ramps and roofs, as my colleague has just been mentioning. So maybe I would want to know if there is a way, because I heard you say that if anyone would want to jump in also to be doing something, maybe with a different approach, is there a way you can let someone also to share his insights concerning the same?
To share the, you're trying to say that if there's a way to share
his insights, a different approach using the same tool, and maybe
yes,
as
yes.
at now,
I
as
don't
at
know.
now I can see.
If you're able to, please do. Are you able to?
Okay. Maybe later when we come to the end.
Oh, okay, no problem.
Okay.
All right, that's very interesting. You can see that the whole, almost half of the community is already embracing this. It's some of the things that if we don't talk about them, it's very many people may be finding it quite a hassle to use some of these things. Okay, great. So let's try the next one, which I have just seen, because when we went to the curved, to the object, we had something which was curved. So I'm going to try it right now, but I believe it's going to work because it's the same concept. So let's do that. We're going to do, what's the recommended width now here for round things? I don't think I'm going to be too strict. Just try to do this. such that I am able to see whether it actually works, and hopefully it should work. Okay, so let's imagine that we have a landing which is somewhere right there. So we will go ahead and do that, and I think we will need some breathing space. And for those who may not like that line, so I'm going to take it outside. Okay, so I don't know how long this is, but we are going to consider that this is going to climb for only 1 meter. Okay, and then we need a thickness to it. Okay, so I'm going to make a copy of this and offset it by, I don't know,
1.2.
okay, 1 point, okay, but of course here it's asking me for the radius, not the distance between. I think I haven't used, anyone who has used distance guidelines before, because I think this is where they might be useful, where you look for a different, you know, dimension to use rather than the default one. Okay, so let's just go ahead and close this thing and close this one. Let's have it like that, and then we just pick this thing and place it in here, and okay, we go in 3D and make the magic happen. So we will just go ahead and raise this one by the 1 meter. Okay, which makes some weird things to happen. Hopefully we are still correct. I think there's a problem. I'm going to do that again to make sure that that is what I want. So okay, I think it's the one I want, so we're going to do that again. We're going to say 1 meter and 1 meter also here. And let's see, we are definitely running into some problems. Definitely what I did not expect, because I didn't try this before. But what my thinking is that this is definitely not the way you want to be doing it. Why? I know now exactly why the problem is. It won't be able to work because the mesh, if I may try to explain, sort of works in these mysterious ways. It has, when you define the lowest point, it will try to make sure that the highest point is as far as possible. Okay, so what ends up happening is that now the highest point is actually here, and this is just like the intermediate. That's why we are having issues. So we definitely have a problem here. So we will try to think through. Now I have a problem for you architects to solve, because clearly, unless I did something wrong, the mesh will not accept us to have a higher height here and a mid height there and the lowest height here for something that is curving around here, which is quite surprising. Okay, perhaps we would have to split this into two and raise a portion of it and raise this one differently, which is what I think we are going to be able to succeed with. But before we go there, let's put a star on this one, and we first complete with the one which I did before, and then we finish with that one. Okay, I hope I haven't lost anyone. Are we clear? As you start to think about the problem we have just created. Okay, now let's do the boxy one. So now the other challenge we have is that once you start to make complex shapes, because sometimes on site you don't have this long span, so to say, so you want to do something like this. Okay, I'm going to ask that you may mute Ignatius. Okay, thank you. So the problem you're going to run into when you try to create something that is a box, I'm going to try to sketch a box here. Yeah, because definitely you may not have all this space to do that. You are going to have something that loops into itself. So how do you deal with a mesh? Because a mesh is not going to allow you to have two different heights at the same point. So let's make the simplest version of what I'm talking about, okay? I'm picking this, and let's just hypothetically say that you first make this, which is a 1.5 wide, and then you have it 4 meters. Okay, and then you create like a landing. Let's just have a landing here. So we're going to make it 1.5 and 1.5. Okay, so we have ourselves a landing, and then we have ourselves here a shorter distance, which is because we have already compensated with 4 meters. So we are going to increase this to reduce this, such that the 4 meters, we remove them from what was happening here. Okay, so here I'm going to take like 7 meters. So I'm going to take this back to 1.5. So that allows us to have a shorter distance because we have already compensated here. And then we have a landing 1.5 by 1.5. Okay, so we have something here, and then we have ourselves 1.5, and definitely the final, which is 4 meters. Okay, because 4 meters takes us back to here, and then we have ourselves this. So now we have a problem where something is looping into itself. Okay, so once this happens, what do you do? Because definitely once you start to add shapes, you add this shape, you add that, you add that, and add that, and finally we have that, which is going to give us a problem because we have 2 points here, and 1 point is going to be on the ground and the other point is going to be up as the landing position. Yeah, so those things usually work in those skewed 3D shapes that are bizarre, where where you start from, you climb and then go back to where you started from, which is not practical at all. But all you have to do, and I think I may not even need to complete this because it's quite easy. What you have to do is to just stop the continuity of this shape and then work on this independently. I hope you guys can understand what I'm trying to do. So once you have done these shapes, I'm going to delete these independent shapes, yeah, such that we just have one continuous shape. So imagine this going and landing here, because all you have to do is to create the same height for these 4 portions, and then create the same height for these 4 portions, which will be higher than this one, and then finally create the same height. Make sure that you have this node, because there's probably a landing here. So you have those 4 portions that are giving you this landing, and then you have this as an independent thing. I hope that makes sense, and I think it's easy. Same procedure that we have been doing. You just need to raise this independently and then raise this differently and do the operations like we said before. Am I being too theoretical? Do you want to see me do it, or it's okay? Yep. Anyone who wants to say something? Yep. Yes, Nixon.
Personally, I think I get the concept.
Have you done it before? Did you how do you usually deal with that?
I
I think I should mute my mic. Okay, please go ahead. Let me just, as something is going on here, I'm just muting.
okay. Like I was saying, I get the concept. I've not really done something particularly like that. I have done something a little bit similar, but I think this is something I'm really so excited that I want to try out and see how that works out for me. And definitely I'll be glad to share the results or any kind of problems I might run into, but I really get the concept.
All right. Anyone else who thinks they also get something, or they have a question, or please go ahead and speak. And then also Nixon. Yes, Ebenezer, please go ahead.
Yes, thank you, Alan. I think I'm just getting to a space of learning a lot of things. That's one thing I've really learned. Literal not being used in this, but then it just looks pretty simple, and of which I know I won't get lost, and actually I can do more complex things with the same idea that you have shown to us. Thank you so much.
Oh, great. So here you have. So I have given you the challenge. Please go ahead and figure out how this thing will work and try it out for yourself. Because definitely, if we give this thing some muscle, because maybe we were looking at it without muscle, let's give it some muscle and see. It definitely, it has not even accepted to add some muscle to it. So perhaps we created a very thin loop. We can always scale it back. Where is the, okay, I'm trying to scale it back. It's kind of working, but not in any expected way, because I don't think this point is highest. You see that? You see what I'm talking about? This point doesn't look to be the highest. But of course, all these might be because we are looping so much. But when you're doing a real life ramp, so perhaps the circle is much bigger. So you may not run into some of these issues. It would just need you to have a higher radius, and then you can have this point higher than any other point on the circle, because you don't want to run into a scenario where people are, you have a high degrees, a high slope in the middle of your ramp. Okay. So definitely once I reduce the enclosure, you can already see that we have something as close as to what would be the ideal. Okay, so that was it for today. We just have only five minutes. You can just say something and say hello to everyone. Otherwise, it has been wonderful to have you today. Please try it for yourself in case you run into any issues. That's why the group is there. People can help in. Okay? You can go ahead.
Hi everyone.
Hi.
Okay, this is Evan speaking.
Yes,
New
Evan.
member. Yes, how is everyone?
You.
Okay, I'm just happy to inform you that I'm a new member in the team, and I must admit that hasn't been my line, and I'm planning to shift. So I'll be very happy to join you and learn much more from you people. Otherwise, thank you for the ad, and I appreciate so much. Thank you.
Okay. Thank you so much. So, just as a quick bonus, is that someone raising their hand as well? I can let them speak. Nope. So, just as a quick final part for you, don't forget you need this thing to be safe. So in order for you to keep this thing as safe as possible, the ramps were made for that. The railings were made for that. So just going to leave you with this. Just pick the railing and just draw it freely. So you can just go ahead and follow the profile, click on all the nodes, and you should have yourself a railing quite simply. And then of course, once you want to make any changes, you can always go in and make them. So currently it's been drawn on the wrong side, so I can flip it here, and then you can see that it is going to change to the other side, which is the proper side for the railing. So that's as simple as it gets. And sometimes for ramps, you don't want to do some of these. Sometimes you want the ramp itself to have a muscle, to have like some thin wall built before you can create some of these things. So what I like to do is to create like a copy of this and make it taller to just exceed. So I'm going to make this what, let's move this by imagine building a wall on top of this of this thing. So I'm going to move it up. So I think I'm gonna need to use one of these. Yes, I'm going to use this. Yeah, this makes much more sense if I click on the node for the blue line. Okay, so this is going to be, imagine we are making a short wall there, so we will use like what, only two bricks, which might be like 300. Okay, and it's increasing in the wrong direction, so I'm going to do that again by clicking and making sure that it is going in the positive direction. And it looks like it's measuring it from the 0 point, so that's why I need it to be 1.3 instead of 1 meter. So yeah, so now it's what I wanted to do. So the only thing that I wanted to do is just to get rid of the shape which is in between. So I'm just going to subtract. You will see in a moment what I'm trying to achieve. So I'm going to just subtract a shape which is in there. So you can already see what I'm trying to achieve is a scenario where we have built, just before we put the railing, we can make some construction on either side. Okay, very common for ramps to do, and then you can make it as thin or as thick as you want it to be. And right now I'm just eyeballing it, and then finally we just use these two as targets, and then our previous shape, which is at the bottom, as the operator. And then we can do the magic that we have been doing. And that's it. So now you have yourself this kind of thing going on where you add a layer of interest to this thing. So which just means that in case you actually wanted to create something a little bit more detailed, you can go ahead and do it, because you can leave some space in this side to just create a detail that you want to create. Okay, I think that's enough for today. It's already 9. Thank you so much for joining in. I hope to see you soon once there's something interesting for us to talk about. And I'm glad to have had you. See you in the next one.